Alright, howdy guys. Today we're going to be looking at how to identify what is called the parent chain of an organic compound. So I've got 7 different molecules drawn out here. Now you'll notice that there are no hydrogens in any of these. I have only put the carbons. And that is because it would take a ton of space to put in all the hydrogens. So I just didn't bother with it. So these are all alkanes, meaning none of them have rings, none of them have multi-bonds. Some of them have branching structures. Well, most of them have branching structures. And what we're going to do is we're going to figure out where the parent chain is. Now, the numbering on this is a little weird. This is 1, 2, 3, 4, 5, 6, and then this one over here is 7. And I'm going to write the name of the parent chain over here as we do them. Now, I would encourage you to try to work ahead. Pause the video, try to take a shot at what you think the parent chain would be for each of these, and then let it play, and we'll go through and I will work my way through them. So first off, number 1. Now, the main thing you want to remember with the parent chain is the parent chain needs to be the longest possible path, where it has to have the most carbons in it that it possibly can. So for example, we could start here, go 1, 2, 3, 4, 5, 6. This is an end, this is an end, that's a 6-carbon chain right there. But is that the longest chain? Well, we could also go 1, 2, 3, 4, 5. Well, 5 is less than 6, so that can't be the parent chain. But we can also go 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be our longest chain, is 8. Now, that means that we're going to use the prefix, which means 8, which, if you remember to what we did last week, 8 is oct. So number 1 is going to start with oct. Now, that is the prefix. The suffix, which goes on the end of it here, is going to be based on the types of bonds that it has. So if you look at that first table on your organic cheat sheet, it says that alkanes have all single bonds, alkenes have at least one double bond, alkynes have at least one triple bond, and then rings, or cycloalkanes, or rings, have to have a ring. So this does not have any rings, double bonds, or triple bonds, which means this is an alkane. So it's going to end in ANE. So that would be, the parent of that would be octane. So now if we look at number 2, there are a couple of paths on this one. We could just go 1, 2, 3. That obviously is not going to be correct. What should jump out at you on this one, you could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's a lot of different paths that give you 5. Since there are several different paths that give you 5, I will tell you that all of them are considered correct. Now, there are more rules that we'll get into later this week, where we talk about how to number the carbons in the parent chain, which is very important for writing out the full name for all of these. But all we're doing is identifying the parent chain. So our parent chain in this one has to have 5. So, take a second, Write down what you think the name should be, the name of the parent chain. Hopefully, you came up with pentane. Now on number 3, number 3 is going to be a hexane. Number 4, if we start here, the only real choice is whether we're going to have one more or two more. Well, two more is more. So we're going to go with the two more. So 1, 2, 3, 4, 5, 6, 7. So 7 is going to be heptane. And like I said, by all means, pause this to take a crack at these before I give you the answer. Now, on number 5, take a look at number 5 and see if you can figure it out real quick. Pause the video if you need to. Number 5 does not have any branches. It doesn't have any branching structures anywhere. It goes straight through everything in one straight chain. So, this is a straight chain with 16 carbons in it. So, 16 carbons, that's 1, 6. 10 is dec. 6 is hex, so this is hexadecane. Almost forgot the E. Alright, now number 6. Now this one has a few more branches in it, so this might take a little bit longer for you to figure out. So let's just start at the bottom and see what we have here. So this is our first junction, and actually when you have something like this, what I would recommend is going through and putting a dot at each junction. And make sure that you're checking all of the possibilities at each junction. Now, from this junction, we have 1 carbon here or 2 carbons here. So this is definitely going to be the preferred option from this junction. Now, if we go up to the next one, there's a 2 carbon over here or 3 down here. Well, that means that we definitely want this, because here 1, 2, 3, 4 is one more than 1, 2, 3. Same thing here, we're choosing between 1 and a lot more than 1, so we definitely want to go this way with our parent chain. And then again here it's 1 or more than 1, so we'll go around like that. So this is going to be our parent chain. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is undecane. And that brings us to the last example that I'm going to do, which is number 7. Here's the catch though. I'm not going to tell you what the answer to number 7 is in this video. I will tell you the answer to number 7 in the next video. So, you're going to have to wait a little bit for that. So, take a look at it, see if you can figure it out. Hopefully the next video should come up soon if I don't have upload issues like I did the last time. So, fingers crossed.